Hey everyone, thanks for coming out, especially since, it's I think before 10 a.m. right now. My name is Lila, and I am a Android developer advocate. And I picked a very long title for my talk, but today we're talking about teaching. All right, so when I say I'm an Android developer advocate, often that does not mean as much as going up and saying, hey, I'm a software developer. And people ask, what exactly does that mean? So the one sentence answer that I give is that I'm at the intersection of teaching and engineering. And I'm super excited today because I actually get to talk about the teaching part of this because they said, what do we want to talk about for a keynote? And I'm like, I want to talk about teaching. So just a little bit of a background in case you have no idea who I am. So I've had a 10-year teaching career, and it started off when I was in college and TA for a bunch of kooky computer science courses. Following that, I spent a summer teaching in South Korea, and then I spent a magical 2.5 years as a Peace Corps volunteer teaching at an all-girls STEM school in Rwanda. And most recently, before my current gig, I was at Udacity as an Android course developer. So if you've seen Android courses, you might have seen my face. The hair color's different, but I'm the same person. These days, I am at Google, and I do things like appear in YouTube videos for a YouTube channel. I give workshops at conferences, and I sometimes speak. And shameless self-plug, a bunch of us at Udacity Google just have been releasing lessons in developing Android apps in Kotlin. And if you want to learn Kotlin for Android, if you want to learn about Jetpack, architecture components, all that fun stuff, or you have somebody new joining the team, please check it out. All right, so it's I guess kind of early if you're a developer. It's sort of early for me. So you might be thinking, like, all this teaching stuff, what does it have to do with me? Like, should I have just stayed in bed? So I guess part of the thesis of my talk is why you should be here and maybe listen to me. So I guess the first point that I want to make, and it's kind of an appeal to our better selves, is that none of us was born a programmer. And I don't think anybody was born an Android programmer. All of us had to do a lot of hard learning to get to the points that we are. And you probably had help from people who were either formally called themselves teachers or informally were teachers and mentors. You should be very appreciative of that. Also, today, a lot of the people that you're going to be here, well, basically everybody who's speaking kind of has that formal or informal title of teacher. And the way that our communities survive and grow is by people taking up that mantle. And now we'll do one of those hand-raising exercises. You can also use this as a stretch if you want to start your day off. So keep your hand up or keep stretching throughout it. I swear it's pretty short. So can you raise your hand or stretch if you've ever given a talk at a conference? Awesome. OK, keep your hands up. If you've ever taught in a classroom. If you've ever replied to a question on Stack Overflow. If you've ever mentored a new team member. If you've ever written documentation ever. All right, well, congratulations, it is you. You are a teacher. In sort of the broad sense that I'm using for this talk, teaching is just the ability to effectively transfer some knowledge that you have to somebody else. And it's an underlying and incredibly important life skill, I think, for just being an effective human. So hopefully I have some tips that relate to these various tasks that you might do or other parts of your life. All right, so when I started this talk, I was like, all right, I've been teaching for 10 years. I have a lot of thoughts. I use this method that I sometimes use where I just take out a bunch of Post-it notes and I put down the major points that I want to capture and I kind of try to select them and sort them out. So what you're seeing is the end product of that. Oh, what you're seeing is the... All right, little review. All right, so what you're seeing is the end product of that, which was dividing this up into 3 overall categories of what I wanted to talk about. I actually had 4 categories, but there's not enough time for everything that I wanted to say. All right, so first on our map for today, I'm going to talk a little bit about setting the tone. And this has to do with things around mindset and just kind of how your message is packaged. Next, I'm going to have a section in the middle about charting the path. Basically, some thoughts about how you take a concept that you want to teach and divide it up into a way that's consumable. And then finally, we'll end with a little bit of a section on feedback. All right, so setting the tone. So a few years ago, I read this article that was both depressing but also very helpful. And it's called The Confidence Gap. And the central thesis that the authors had for this article was, number one, that confidence is extremely important. It is as important, if not sometimes more important, than your actual competence and ability to do something. And the other point was that, in general, women tend, from study to study, to exhibit less confidence than men do, and that this really affects them. Everything from their propensity to put themselves up for promotion to even apply to the job in the first place. And there was a bunch of studies in the article, and one of the reasons that I pointed out is I think it's just a good overall of sort of the state of confidence and thinking about it in respect to gender. But one of the experiments that I thought particularly related to teaching or sort of spoke to me was kind of a little bit random. So there's a series of 4 experiments, and I'm just going to cut to the end with the 4th one. All of these experiments involved giving a test. And the test was taking 3D objects and mentally rotating them and trying to be able to look at a 3D object, look at different rotations of the object, and determine which rotations were valid. So this is a test that has been given and has been shown to have a difference in how men and women do on it, and men tend to do a little bit better. But in experiment 4, the early experiments kind of showed that this was like pretty related to confidence as opposed to competence and ability to do that. And if you got rid of the confidence issue, you were actually able to get pretty much similar results for both genders. Experiment number 4 was interesting because what they did was before they gave the actual test, they gave a little pre-test. And in the pre-test, after you did the pre-test, you were randomly told whether you did well or did poorly. And across the board, if you were told that you did well, you actually performed better on the actual test. And if you were told that you did poorly, you performed worse on the actual test. And this was, gender agnostic. So how does this relate to teaching? Well, I think the number one thing that I want to point out is that confidence affects all of us. And being told that you're not good at something affects all of us. It actually hurts our ability to do things. But also, as you are teaching, depending on what medium you're teaching in, especially if it's online, you don't necessarily know every single person who's going to be in your audience, especially if you put content out online. And even now, as I'm sort of live teaching and I have an audience in front of me, I don't know all of your life paths and the different things that you've gone through. And you're going to have, most likely, a pretty diverse audience. So you should put some of your brain space and thought towards the experiences they might have going in that could potentially give them different confidence levels coming into a teaching experience. Okay, and if you'll, and this is actually a pretty clear example of something known as stereotype threat. So stereotype threat is the idea that you're part of a minority group and there might be some negative stereotypes associated with that minority group. And simply because you are thinking and know about those negative stereotypes, they actually affect your ability to do something. Okay, so if you'll humor me, there's one other article that came out around that time that also had a lot of interesting experiments and information that I definitely encourage you all to read. And it's called Who Gets to Graduate? So it started off with a pretty dire statistic, and it's that of 40% of students that go off and intend to finish a 4-year college degree, 40% of them don't graduate in 6 years. But if you dive into the backgrounds of those students, you discover something that at least gets me fairly angry. And it's that if you come in at the bottom half of the income bracket, you actually only have a 25% chance of graduating on time. Whereas if you're coming in at the top quartile, you have a 90% chance of graduating on time. And in sort of plain text and actual sentence for the article is basically rich kids graduate, poor and working class kids don't. And that is, I think, a fairly upsetting thing. The rest of the article kind of goes into why this might be the case. And one of the first things that they debunk or kind of talk about is that they took students, they looked at their incoming SAT scores. Because one of the things you can say is like, oh, if you come from a poor working class background, you just didn't have access to the same tutors, maybe your high school was worse, that's probably why there's this gap. And while I'm sure that certainly factors into it, they took kids with comparable SAT scores, and even with that, there was a 40% gap depending on your income coming in. So what else could be at play here? Well, the article kind of goes into two other things that could be at play, or that are hurting students, especially first-generation college students. And the first thing is this idea of belonging. So students who are first-generation college students or just came from a different income background than most of the folks there had this constant sense of otherness and that maybe they didn't belong there. Thus, if they hit some sort of academic challenge, the way that it was often interpreted as was a verification of this lack of belonging, and that this lack of belonging actually had something to do with their abilities, and that they were failing because they were always meant to fail, and they just didn't belong on campus. So that brings me to another definition for something called imposter syndrome. Who has heard of imposter syndrome? Who's experienced imposter syndrome? All right, some hands going down. Well, I've definitely experienced imposter syndrome. I am experiencing imposter syndrome for this talk. Like, it is actively happening in front of you right now. So anyways, imposter syndrome is the phenomenon where you could be extremely successful and knocking it out of the park, but you attribute that success to either just lucking into it or somebody making a mistake along the way. And that leaves you with this overall sense that you're a fraud. And essentially it is about belonging. Like, I actually don't belong here, I'm an imposter. You might think, I don't, okay, yeah. So as a teacher, what can you do about this? It's kind of funny. It's like at one end, if somebody's struggling, they might be struggling due to stereotype threat, and on the other end of things, even if they're highly successful, they might have this cloud of imposter syndrome hanging over them. All right, so at Udacity, there was this book that, at least at the time that I was there, was almost required reading. And it was called Mindset, the New Psychology of Success, and it's by Carol Dweck, who's a Stanford psychologist. And basically, she has done a bunch of experiments over her career related to learning and confidence and the ability to come back from failure. And the very TLDR thesis of her book is that there are two types of mindset. The first type of mind that a person can have, and you can change your mindset, and you might have a different mindset depending on what the topic area is. But those two types are fixed mindset and growth mindset. So starting off with fixed mindset is the idea that talent and ability is innate, that it is something in your DNA, that you're born with it, and it doesn't change. Who here has heard, if you've ever heard the phrase, I am not a math person. Like, I opted out of taking calculus because I'm just not a math person, I'm not good at it, or I'm really bad with languages, I'm just bad with languages, I cannot learn French. These are kind of out in the world examples of fixed mindset and how it manifests. On the other hand, there's a group of folks who are able to nurture and foster what is known as a growth mindset, which is this deep understanding that the brain is malleable, that people change over time, that you can learn new things, and that what matters is that you have perseverance and you keep at it when you're learning something. And basically, in study after study, it was shown that even if you were somebody that came into it that was maybe good at math and was doing better at math, if you had a fixed mindset and you hit a problem, even somebody who maybe came from behind but had a growth mindset would do better. All right, so I'm trying to set this up in a way where it's like we have our problem, stereotype threat, imposter syndrome, and we have some ideas about how we might have a solution, which is to encourage confidence and encourage folks to actually think about having a growth mindset. So let's talk about some examples of where you might be able to use this. So number one is when you are communicating, not even, I won't say even teaching, but just when you are communicating with folks, try to avoid language like it's obvious or it's easy to see, okay? Because it might be obvious to the person that you're talking to, and great, that's fine, you continue on with the conversation. But if it's not, that's a problem. For example, if I say this podium here is bright green, and everybody seems to be going along with that, and you're the one person who's like, well, it doesn't look green to me, you immediately have this feeling of like, do I belong? Like, am I actually seeing the same podium? Maybe I'm colorblind. These thoughts can kind of cycle from that. Okay, so in a more concrete way, how that potentially relates to our communities. So about a year ago, Stack Overflow did this really interesting thing where they were basically rewriting their code of conduct. And this was in response to the fact that they were discovering that there were a lot of kind of nasty comments on the website. And in particular, it was scaring away newcomers and folks in minority groups. scaring away newcomers isn't so great for a site that's all about answering questions. So I guess one of the things that I found interesting, so this is an interesting article. There's a couple of interesting follow-ups to data that they poke into related to that. But I think the interesting thing is they weren't focusing on things that were just overtly like terrible, overtly sexist or racist comments. It was the in-between comments where people would have sort of snarky humor or sort of subtly put each other down that they were looking into and the effect that it ultimately had on their community. All right, so point number 2, don't aim to make something hard. Anecdotally, just talking to people, I've heard stories of professors that might, and it's usually like an introductory STEM course, where the way that the professor phrases it is like, this is a really tough course, and the point of this course is actually to weed some of you out, and only the strong will survive, and then you'll make it to the end and you'll become an engineer. Okay, so there's a lot of problems with that, but I think the major problem from kind of the stuff that we've been seeing is that the people that you're going to weed out is going to include some proportion of people that are just because of the messages that they've been getting throughout their life, a little bit less confident, but potentially able to succeed wildly. And there's almost like a social justice bent to it, where you shouldn't be doing this because you are hurting people who are already you're punching downwards, I guess. Okay, so some concrete ways that you can think about this. So trick questions, please try to avoid them. Usually a trick question is just about making yourself feel smart in comparison to the person that you're asking it to. Yeah, so in Udacity we have this like across the board rule that we avoid trick questions. Another thing to think about is just think about the complexity of the language that you're using. I don't mean like computer language, but when you're explaining something to someone, especially as engineers, there's a lot of technical terms. And if you explain something to someone and you're introducing 10 new technical terms, that makes it that much harder to understand. And you should really think about whether you need to necessarily have that level of complexity in your language, and whether you could figure out ways to simplify it. Okay, so number 3 is to get diverse reviewers. None of us are omniscient and able to understand everybody's perspective, so often a shortcut to being able to just get a fresh set of eyes on your content is to actually go out and make sure that it's getting looked at by people that represent all parts of your audience. All right, so I would say the first 3 tips are more reactive or kind of things to avoid. I want to talk about some ways that we proactively tried to do some tone setting. And the example that I'm going to use is Android Basics. So Android Basics is an online course on Udacity. And going into it, our goal was that our incoming student was not going to know how to program. And at the end of it, they were going to be able to make their first Android app. So we knew that we were going to want to do some things explicitly around getting people comfortable programming and building up their confidence in regards to programming. So sort of going back to the article about who gets to graduate, they actually go through a bunch of studies, namely mindset and belonging interventions, and that they did with college students and sometimes younger students as well. And one of the things that you see is that even short interventions, so even something that takes an hour or maybe even 30 minutes, can actually affect graduation rates. And the way that you set up an intervention like this is you kind of think about 3 things, or you try to get 3 things to be true. First, the viewing of the intervention or the interaction with the intervention is something that's autonomously chosen. Like you're not forcing people to come into a school auditorium and telling them not to do drugs. Now, for Android Basics, since it's an online course, I think the assumption is that they're choosing to view this online course and nobody's forcing them to view it. The next is to appeal to social norms. So messages are consumed a lot better if it's coming from a peer as opposed to somebody in a kind of outside group. And finally, there's this idea of self-persuasion. That's basically if you present a story about somebody inhibiting or gaining a growth mindset, the ability to then have your student take that story and then either write like a message to themselves, try to talk about how it applies to them, or better yet, write a message to future students trying to convince them of this fact. Okay, so we tried to do this at Android Basics, and I guess my overall bullet point for this is just encouraging everybody to be vulnerable and kind of talk about it. So what we did was we actually had a video on imposter syndrome. And we got a bunch of Googlers from across Google and at different stages in their careers to talk about imposter syndrome. So we really were trying to kind of appeal to social norms and get different folks that students might be able to kind of map themselves onto. And then immediately following up that video, we asked them to reflect on imposter syndrome and specifically talk about what their tips were and share those tips for dealing with imposter syndrome. And I'd like to say that this is a pretty clear example of asking folks to do self-persuasion. If you Google my name, one of the videos that you might see is a video that was part of a Udacity series about failing interviews. So I sat for about 5 minutes and talked about my struggles with interviewing. I am not a great interviewee. It is something that I get very nervous about. I guess part of that is whether you write a blog post about it, whether you record a video, whether you even share a tweet, just talking about the fact that you were a beginner once and that it hasn't all been rainbows and unicorns in your career and you've been able to get over it and do some really impressive things. I think that could be a really helpful message to put out into the ether. Okay, so next, encouraging a growth mindset. So this is also something that we explicitly tried to do. So the imposter syndrome video comes up a little bit later in the course, but the first, I'm pretty sure the first interactive thing that you do in the course before you learn any programming is you actually are presented with this question, which asks you to think about a time in the past, doesn't have to be programming related, that you struggled to learn something new and that you overcame that struggle. So this is both pointing to the fact that you are capable of learning something new and that even if it's hard, you have that ability to overcome failure. And similarly, it was shared, so similar ideas with self-persuasion there. Okay, and then finally, there's the idea of starting off with a win. Usually it's good to start off with a win as opposed to a fail. So I don't know if this will necessarily work, but I'll give a semi-rhetorical question of what is the first challenge that you think students hit when they're making an Android app? Hearing rotation, maybe? That's pretty hard, but actually, if you look at our, so unsafe instance state, very difficult. So what I would like to posit from not super scientific, but just life experience, is that the first challenge is freaking installing Android Studio. So like in any kind of in-person workshop that I do, the installation process is this just constant like fear and dread over how long it's going to take. I mean, usually I'm dealing with conference Wi-Fi, which in itself is kind of a cluster beep. But anyways, so it's hard. But even if you have a fast Wi-Fi connection, there are some challenges that you might not think about since we've all had our development environments set up for a while. So first, if you're new and you've been told to download some sample code and run it, you might unzip and open up the wrong folder. It's hard to know which of those folders to open up. There's one called app. Why don't we open up that one? The Android Studio UI can be like a little bit overwhelming. And these days you get a couple of pop-ups and things that come out. If your Gradle version is a little off, you're immediately assaulted with these things that are like, you gotta update Gradle. What is Gradle? I'm making an Android app. So similarly, one of the random things that I've discovered when you're watching students is they'll open something up, looks like everything's working fine, nothing's red, but their play button for being able to run the app that they've been told is the first step that they need to do is grayed out. And I know that that's because Gradle is downloading a half gig of dependencies or something in the background, but they don't know that, and they think that they've already failed, and there's no way to fix it. Okay, actually, I'm gonna go back. Don't wanna sneak peek. So what did we do? So we understood that the experience of downloading Android Studio was a pretty tough one and could be fairly demoralizing. It is easier if you have a physical person in the room there helping you, but if you're alone at your computer and this is your first experience with programming, that is a really hard hurdle to get over. So what we actually did was we put engineering power behind this, and we had somebody on our team, awesome Ben Jaffe, develop this sort of web app that basically was like the Android Studio design editor, but in a web app. No installation required. And in addition, students could do, they could start programming their XML layouts, and they could see them being able to work and build something immediately, pretty much. And I guess another thing is because it was on the web and we sort of scoped it down quite a bit, that feedback came really quick, which is very important when you're trying to learn something for the first time. All right, so start with a win. So I guess my tips in relation to that would be if you have any sort of setup or installation flow, pay particular attention to that. That is where you're going to lose people potentially. And take a little bit of time to try to pick empowering examples, visual examples, things that they want to show friends and family. All right, so obligatory slide that kind of summarizes things up. So don't imply that something is easy if you can avoid that language. Certainly don't aim to make something difficult. Make sure that you get to reverse reviewers. Consider if you are comfortable enough being vulnerable and kind of talking about your beginning experiences, and actually talk about things like imposter syndrome and things that your students might be experiencing. Explicitly encourage a growth mindset, and if you can, start off with a win. All right, step 2 is charting the path. So I'm going to start with a little story here. In 2014, Google and Udacity made their first online Android course called Android Fundamentals, and it featured these 3 wonderful individuals. And these were actually my Android teachers, because I joined shortly after the course launched, and it was actually one of the first things that I watched. In the biz, we would call these guys subject matter experts, technical experts in their field, whereas I had the official title of course developer. And the idea was essentially that I was a teaching expert, and then we had folks that were subject matter experts in Android, and together we would work together and make this beautiful course that both was technically accurate and well taught. So I'm getting ready for my job for Udacity, and I am taking the course, and I get to lesson 4 of the course, which is all about content providers. First of all, thank goodness for Room. But at this point, content providers was the way to go, having a content provider built on top of a SQLite database. And I got to this part, and it got stuck. And I had an imposter syndrome-related panic attack where it's like, oh my God, I cannot get through this thing that I need to be teaching people soon. What is wrong with me? Well, on the other side of things, when I actually got to Udacity and looked into the data, I was not alone. This was actually a lesson that I still hear people talking about when I say, oh, have you done a study jam for developing Android apps? And they say, yeah, we did a study jam, and everybody got stuck on the content providers lesson. So some reasons why this is the case. Well, there's a ton of classes up here. I hope that this is illustrative that it's a fairly complicated flow. And actually, the first time that the course launched, you didn't even have this diagram that was showing things. You were just kind of skipping around in Android Studio between different parts. And the results are also kind of invisible. You essentially spend 2 or 3 lessons doing stuff in the back end, and you don't see anything change on screen. So we made some tests to try to be able to test that things were going correctly. But we hadn't taught testing before too, so this was also another topic that they had to learn. It was just a lot of information. But one of the subtler things that I kind of felt or saw as I was going through is while all of these new topics were being introduced, I actually found that sometimes core definitions would either be said really quickly or would sometimes just get glazed over entirely. Okay, so I do a lot of feedback on different trainings. I work on the training team, and we share the materials that we're working on a lot. What do you think is the most common piece of feedback that I give? And Sean can't answer because he knows the answer. Okay, yeah, well, this is probably a good example here. We're going way too fast. I think slow down is a broad characterization of the feedback that I give. Hey, what I was just talking about. Don't forget definitions. We work a lot in Google Docs, and if you look at the comments that I make, I would unempirically say that maybe, 25% of them are like, what does this word mean? You have not defined it. Give me a clear definition. So I think what this kind of fits into is an idea that was also kind of a word that was thrown around a lot at Udacity called expert's blind spot. It's essentially this idea that if you are a super smart, amazing expert, you 100% know how to get to the end point that the student wants to be at, and you are definitely an expert at that. But it has been so long since you've learned it yourself, breaking it up into the component steps to get to that end point can be actually a really difficult task. It's this idea that you don't really know everything you know, and that kind of plays out in just throwing out 10 new words without defining them. All right. And this is not something that is rare or just in Android. It's actually a phenomenon that's been shown kind of across the board. So there was a study where they actually took professional math teachers and educational professionals, and they gave them a bunch of algebra problems, and they said, hey, look at these problems, tell us, rank which ones you think are going to be the most difficult for students that are in your math class. And systematically across the board, what they thought was going to be difficult deviated from what students actually found difficult. And these are educational professionals. So experts blind spot is not a super easy thing necessarily to deal with. Okay. So a corollary or sort of side point that I want to make to this is that a big part of teaching is being able to come up with a path for students. There are a lot of places to learn Android online. You could read the reference docs. You could look at Stack Overflow questions. You could go through code labs and tutorials and blog posts. Or you could take online courses, and I'm sure there's a couple other things that I could also fit in here. But I guess what I'm trying to say is at the top of the list are these incredibly information-dense tidbits, and reference docs are really great. But if you tried to learn all of Android just by popping around to different reference docs, that would probably be a fairly painful experience. And as you kind of go down that list, the flow is more, the path or flow to learning is more defined for you. So especially for beginners, I think there's a huge benefit to having a path through the information. And as you are teaching something, that's one of the things that you should be thinking of as opposed to just throwing out random bits of information. All right, so how do we create a path and how do we avoid expert blind spot? All right, back to content providers. So one of the first things that I actually did was create supplemental content to attempt to make this an easier lesson and get more students through it. And so the first thing that I wanted to break down is like, what even is a content provider? We spend 3 lessons making one, but when you're in the midst of lesson 2, you're like, why am I even making this thing? Like, I have a SQLite database. So one of the ways that we simplified things was to actually give them a pre-existing content provider to start with and have them play around with that first before they go off and they make their own. And just visually trying to show how that simplifies things. The first graphic that they're shown with that is a much simpler graphic than the one that I showed on the last screen. So for creating a path, the first most important thing is to really aim for simple. And I'm going to give, well, let's talk a little bit about this. Okay, so we have this continuum of complexity from the simplest example to full, robust production code that you see out in the wild. So I think there's this fear, and it's a realistic fear, that if you give an example that's way too simple, there's too little to build upon, and they haven't learned actually the skills that they need to be performant in the workplace. On the other end of things, if you jump immediately to the most difficult thing that you can think of for production code, it's hopelessly complicated, and you've completely lost your student. So you try to get somewhere that's somewhere in the middle. But I have found, and this is something that I definitely struggle from, and I shoot myself in the foot all the time with this, that time after time, we tend to get pushed out closer to full production code. And this pushing is actually something that I see more from the engineering teams that I work with, because they really want to get something that shows absolute best practices. And that seems like a very sensible thing, and it is a very sensible thing, but if you just listen to that part of yourself, you tend to end up with something that's way too complicated. Okay, so let's take a look at an example. So in Android fundamentals, the first coding example that we showed off is an app called Sunshine. I'm just kind of generally curious, who's worked with this app before? Wow, all right, cool. So you guys all probably have ideas about Sunshine, and I did find Sunshine as a very helpful example. Sunshine teaches a lot of things. It teaches layouts. It teaches networking. It teaches you implicit and explicit intents and navigation. You're also learning recycler view, preferences, databases and content providers, loaders. There's a lot of information embedded within this app. So as we made additional iterations of the course, we had this idea of, or we were trying to think about whether large code samples are good, bad, like what size of code sample should we give? And basically from a lot of experience with this, what we found is that while Sunshine is great in some respects, sometimes it can hurt us because essentially we had 10 lessons and probably, maybe many hours of content, tens of hours of content, all with this one example. Now, when you start off the course, things are super simple, and Sunshine is a very simple app because you're just, you're pressing new project, get started kind of thing. But as you get to lesson 10, Sunshine has become this pretty big app, and when you try to add a new concept on top of that, it becomes a pretty complex, playground to be learning something new in. And then sometimes a side effect of that is that adding this new concept requires some amount of refactoring. And refactoring, or some edge case that you had to deal with or something like that, which both can be confusing for learning and also isn't a super satisfying learning experience when you're told to throw out a bunch of code that you just wrote. Also, it didn't allow us to pick examples that were the best examples for the particular thing that we were trying to teach. So for example, I remember learning sharing and sharing weather. Do we share weather? I don't know. And then from a behind-the-scenes perspective, Sunshine became this app with like over 100 steps that we had to maintain. And the reality was we just didn't maintain it a lot of the time. So, which obviously that is not great for students. So in the new iteration of the course, Developing Android Apps in Kotlin, we are going towards smaller examples, and we only do a single example per lesson. It allows us to kind of start things afresh and really pick examples that are powerful and focus on what the student is currently learning. And so you can see some examples of that up here. I want to dive into one of those examples. So one of the parts of developing Android apps in Kotlin that I really wanted to teach was the architecture section, because I've been doing a lot of talking about architecture. It's something that I've learned a lot about recently in the last 2 years. And when we first launched architecture components, and we put up the guide to app architecture, this is Google documentation thing. This was the diagram that is presented in our documentation. And looking at this and thinking about teaching it, I was immediately getting like flashbacks to content providers. Like, this is going to be so complicated for students. Like, I cannot teach all of this in one lesson. And another thing that was like kind of analogous to the content provider things is a lot of the reasons that you make decisions about this have to do with testing, and we decided not to do a testing lesson in the course. We're hopefully going to do it in the advanced course, but not in the initial course. So I went back and I said, okay, I'm going to aim for simple. What is the absolute simplest version of this that I can show, and we can build it out from there. So that first app that they build actually only includes these new concepts. So they learn about view models, they learn about live data, and we also stick a little bit of data binding in there because it turns out to be pretty helpful in this use case. This is the app they make. It is, if you've ever played the game Heads Up, it's sort of an homage to that, but it's a charades-like game where you get words and you point the phone out away from you and people are guessing those words. Okay, so I knew I had gotten down to what I thought was the simplest example for that, so now I was going to go ahead and start charting out my learning path. And the first thing that you do, if you're doing especially like a training or something like this, but even for a blog post, this could be helpful, is to start out with your start and your end goal. So I'm going to throw a start and an end goal up there. So a student knows nothing about application architecture, and at the end of it, they understand live data, view model, and data binding. This is actually not the most helpful way to frame your start and end goals, because really, and this is one of the things that we really pushed into the minds of course developers at Udacity, you want to focus on what the student could do, because what the student could do is the important part. And we are kind of blessed to be in a field where you do a lot of things, like you are making things very concretely. So let's take that, let's turn it into something that the student can actually do. So I could even get more specific than this, but basically like they can actually create a view model, they can identify what goes in the view model, they can move it over there, and they can make reactive UIs using live data and data binding. Okay, another question that I've kind of had some opinions on over the years is whether you should start with code or an outline. And this relates to focusing on what students can do. So what I have found and heavily suggest is that you always start with code, because that forces you to think about what students can do. If you're trying to teach something and the code doesn't support it, it doesn't have steps or things in it that relate to what you're trying to teach, then you probably have to change the code around and rethink how you're doing it. I always start with code as opposed to jumping right to like a theoretical list of topics that I'm going to teach. Okay, the next thing is to be explicit about your prerequisites. And we actually do this. This is an example of a code lab that we have up. So at the beginning of many code labs, we try to make sure to both give the prerequisites for what they need to know. And helpfully, if you don't have those prerequisites, we try to point you in the right direction for where to gain those prerequisites. And then we also put sort of what you're going to make and get them excited about what they're going to do. If you are ever writing a blog post or even potentially answering a Stack Overflow question, kind of framing things this way and telling people what the background information that they need to know is super helpful. And you see that we do this all over the place. Okay, so let's change this into being explicit about our prerequisites. So we assume, at least in this lesson, that they know about basic data binding, and that's because we teach them that in an earlier lesson. And we also assume that they know about some issues with the Android lifecycle, because that's a lot of what I use to prompt why they're learning this new stuff about view model and live data. Okay, so some things to think about in relation to that. So this is actually one helpful way to attempt to avoid expert's blind spot. And you just have to be really strict with yourself about this. So if you don't explicitly list it as a prerequisite, then it is something that you have to teach. Because if you don't explicitly list it as a prerequisite and you don't teach it, that is a gap. That is a blind spot that you are allowing to exist. Okay, and then pretty much it's rinse and repeat. So you you start from your starting point. You think about you aim for the simplest next place that you can take them in the path. You check all those other things that we were talking about. So, aim for a simple first jump. Define what that end goal is going to be. Make sure that end goal is something actionable that the students are able to do. So you should never use the word, they now understand this thing. You should say what actionable thing they could do that proves that they know this thing. And then just make sure you're not teaching anything that's not a prerequisite. As they move along in your learning path, you're going to have taught them some things before, so you can now assume that they know those things. Yeah. So just diving into this example for a second longer, this is actually not the first thing that students learn. The first thing I did was go, okay, which out of kind of the three topics can I teach them? Live data, view model, or data binding? And after some deep thought about this, it turned out that view model seemed to be the right place to take them, so they learned how to do a view model first. They actually don't put anything in the view model, they just get it going and add some log statements to kind of see how the view model works. And then we have a sort of lesson where you look at the things that are currently your activity, you choose which ones go over to the view model. And after that, then we wrap it with live data, then we talk about how to properly encapsulate live data. It's these small little steps, the simplest steps that we can to get them to a pretty powerful end goal. Okay, another thing that's helpful that I see missing a lot, sort of similar to the definitions, is just making sure to tell students where they are. We do this very explicitly in Android for Android beginners. Kunal, who's one of the instructors, really likes these like physical maps of where you are. So in Android for beginners, we make this coffee bean trail that has like overlaid graphics that talk about kind of the position of the students in the learning material. You can sort of see another example of this here. But in your work, this could be something as simple as numbering steps. Another thing that is kind of a corollary to this is that you should make sure to open up your examples and things by telling them the cool thing that they're going to be able to do at the end and kind of what that northern light is and that goal at the end. And then I didn't want to make this a fully separate step, but we've thought a lot about making sure that students don't get lost so that they can get back on track easily. In the first iteration of the course, we would have these questions which were basically like, hey, okay, we talked a little bit about toasts. Go out to the documentation and implement a toast. Go forth, students. And if they said no, they were unable to do that, they got this response, which wasn't super helpful. So this kind of puts you in a situation where, so one, you're successful, sure, that's great. Two, maybe you're hopelessly lost and you just drop the course right there. Or three, kind of the worst case scenario is you think you've done it correct, but you have some little thing that you did wrong, and then 5 steps down the line, things are broken and you're totally lost. So, we put a lot of energy in making sure that students can get back on track to the extent that all of our samples have a GitHub history, Git history, where we very clearly, basically it's a doctored history where every single commit is a step that the students will take, a perfectly executed step that the students will take. And they can actually go in and they can look at all the diffs, and there's a commit for every branch, or there's a branch for every commit in this case, and if you need to get to any state of the code, you can get back to a certain state of the code. So if you ever get off the path, we help you get back on. And we also do a thing in addition where we leverage the fact that Android Studio is pretty helpful about pointing out where there are to-dos in your app. And for each of the steps where we ask students to do things, we put to-dos in those steps that point them to the explicit places in the code that they can edit things. I'm not going to lie, this is a fair amount of work, but for the scale that we teach, it is helpful to be able to offer these things. Okay, so I guess I'll finish off this section with what is the opposite of expert's blind spot. I tried to see, and if anybody knows if there's like a scientific or even not scientific, if there's a word for this, please let me know. But I came up with something like novice's insight, or just basically the power of being a novice. So beginners are great trail guides, or great people to know what the path looks like, because often they just took that path themselves. And whether that path was neatly laid out for them and there was a bunch of resources that they could use, or they had to do a little bit of bushwhacking, there's a lot of information that you get from having just learned something. So, if you're here and the stuff that you're learning in these talks is something new, that's actually a really cool place to be learning-wise and also teaching-wise. So while you're learning new things, make sure that you keep notes while you're learning, track what is hard, track the questions that are going through your mind. That is educational gold. Okay, so here are the 6 steps. So aim for simple, always aim for simple. Start with a start and end goal, then make sure that those steps that you're doing are actually actionable things. Be explicit about your prerequisites and ruthlessly teach anything that you have not explicitly listed as a prerequisite. Try to tell students where they are so they know where they're going and they know what skills they currently have. And then just being a beginner is an asset in a lot of cases, and it kind of counteracts expert blind spot. I was essentially a professional beginner for like the first 6 months of my career at Udacity, and I believe that I was helpful. All right, so the last section, which is pretty quick because I know you want to get to new things. So seek feedback. So at least for online courses, there's this problem where things, at least in the situations I have been in, have been pretty waterfall model-esque. So you'll make a course, and that course takes 6 to 12 months to make. So anybody who's bugging me on Twitter about the last few lessons of in developing Android apps in Kotlin coming out, I'm very sorry. It always takes us like 12 months, even when we try to go faster than that. Then on the other end of things, you release this beautiful course into the world, and the statistics for how many people get through online courses is about 5 to 15%, and we track to that. So that's kind of depressing. We do explicitly ask for feedback. This is just an example in one of my courses where I asked students to fill out a survey, and that is helpful, and I read a lot of the feedback. But this is a kind of doctored graph of what that feedback looks like. So a lot of people will take your first lesson. And then there's a huge drop. You get some amount of feedback for the second lesson. Then there's another huge drop. And then you have this section at the end with students who are pretty much in it for the long haul, who really love you as an instructor and who are going to finish the course. The issue with feedback here is that you might get a bunch of feedback for the first lesson, and you'll get some feedback for the second lesson. But by the time you get out there, you get less feedback, and also that feedback is heavily biased. It's generally your biggest fans who have stuck around, to the bitter end, and they say, "Oh, you're great," but obviously there was a bunch of people that didn't get to lesson 6. So what's going on here? It is really hard to get feedback from folks that don't like your material sometimes, as opposed to the ones that do, because the folks that don't like your material generally aren't super invested. Speaking of which, if any of you have any feedback about Udacity courses, please come and talk to me. I always love feedback, good or bad. Okay, so one of the things that I did when I was still working at Udacity was I had the chance to actually exchange some email messages with folks who were in our Android Nano degree and ask them why they had dropped out. But the thing was that a lot of the time, the reasons for why they dropped out were not things that really related to my teaching style. It was like they got a new job, or in worst cases, they had suffered some sort of medical injury, or they had to help out a loved one who had. Okay, so all of this is just to say, maybe don't get feedback after you've spent 9 months doing, your beautiful online course, or whatever it is, or your blog that maybe didn't take 9 months to write. Get feedback early on. I have a really hard time with this because I'm a perfectionist. I don't know how many of you would give that label to yourself, but I'll admit I struggle with perfectionism. And I want whatever I release out into the world to be this beautiful, shining, finished thing, and everybody claps and says it's great. But what that keeps me from doing is actually sharing it early. So what I try to remind myself of is the 80-20 rule. The 80-20 rule is that 20% of your work, and this has been shown in a bunch of different fields, but 20% of your work is going to be responsible for 80% of your output. And then the rest of the 80% of the time that you're working is responsible for that last 20%. So you do a bunch of work up front and you get kind of the shape of it, and then you're just arranging the deck chairs after that. So what you want to do is you want to do 20% of that work, and then you want to show it to somebody, even if it's not perfect. So in practice, a great way to do this is to make an outline and show the outline before you commit to the whole thing. Or you have a talk, sit down with somebody, and just verbally talk through what you're gonna chat about. Okay. Kind of going back to review. Review is extremely important. It's important to pick the right reviewers. So you want diverse reviewers. So you obviously want some. Oh, I said obvious. Okay. That was just a live example. Don't do that. All right, so you want somebody who is an expert. So because they're going to be the ones who can tell you whether your content is actually technically correct, so that's super helpful. But you also want people who are stand-ins for your students, and you want them to read through and have them even summarize, kind of what they got out of your material. And then I would say optionally, if you are privileged to have somebody like this around you, and thankfully I am privileged in that I have a lot of people who care deeply about education around me, I usually also try to share with somebody who's either taught it before or has really strong teaching skills. Because even if they don't have the same perspective as the expert or the student, sometimes they can take what the expert and the student say and come up with really interesting ideas about how to present that content. Okay, 3, definitely do run-throughs. At Udacity, we actually have this cool thing where we have a network of students that we send, we kind of do like an early access program, and we send scripts out and let folks read them and give us feedback about that. So we're really lucky to have that. But one of the things that I do myself is when I make training materials like code labs, which are these written tutorials, what I'll actually do is I will find a coworker who wants to learn whatever I'm teaching. I'll book an hour or 2 hours on the calendar, and I'll say, okay, you're going to take this code lab, and I'm just going to sit here quietly and observe you. Like, I hope that's okay. And I ask them while they're taking the code lab to verbalize everything that they are thinking and doing, and I take notes on it while they're doing it. And then the important part of this is when they get stuck, don't immediately go in there and help them. See what happens, see what they do, because this is really helpful information about what the students at home who don't have you standing over their shoulder are going to do when they get stuck. And you can either see whether they're able to use whatever methods you've provided to get unstuck, or whether they're hopelessly lost, and then you can think about what would need to be done to get them unstuck. Okay, and my final tip for today is to think about maybe incorporating design thinking. There could be an entire talk given about design thinking. I will leave you with this link. The D School is actually a school that at Udacity we all went and visited one time and learned about a bunch of this stuff. But essentially, it's these ideas of getting a group of people together, doing these super fast iterative brainstorms, and then rapidly prototyping that stuff. And for the last 2 Android courses that I've worked on, we've done these kind of sprint sessions. If nothing else, it's really great because if you have a team that's from all over the world like we do, it gets us all in the same room and kind of level set on what we're going to teach. But more practically, we sit down and we generate just tons and tons of ideas. Specifically, the things that we focused on for these last 2 were what apps that we were going to teach. But we get tons and tons of ideas about interesting apps. We have this really energetic portion where we sketch them all out on index cards and kind of prototype them. And then importantly, we show them to both stakeholders that are making sure that the course gets made, and then also prospective students. And we get their opinions about it, and we iterate quickly on it. Okay, so for feedback, just 4 things. Get feedback early on. Remember the 80-20 rule. Do 20% of your work, and then find somebody that you trust and get feedback from them. Find the right reviewers. Make sure that you're doing run-throughs, and if you want to go a step beyond that, you could even incorporate a sprint or some design thinking in your feedback process. All right, so some final thoughts. I've talked about 3 things, and I've put a lot of tips up on the board, but I kind of wanted to summarize these a little bit. So the first one is that we are all growing. We're growing today in both the fact that you should encourage your students to have a growth mindset. I hope that you can take that within yourself, that even if you're not good at something right now, we all had to learn to get here, and we're going to continue learning. The second thing from charting the path is experiences in everything. In fact, we saw some examples of experts' blind spot where actually being a beginner was extremely helpful. So as you are learning new things today, if you're taking notes and as you're consuming this stuff, like that is really an important experience to have and potentially document. And if you are thinking about teaching or talking, I just want to encourage all of you to give it a try. Maybe you could be here on stage next time, and yeah, so I'll leave you with that. Well, actually, I'll leave you one more thing. So teaching is definitely one of the hardest things that I've ever done, but it's also been one of the most rewarding things I've ever done. So if you're considering it in any capacity, whether it's speaking on stage, teaching in a classroom, writing down your thoughts in a blog post, any sort of teaching that you're thinking about, I just really encourage you to go for it. So as we enter day 2 of DroidCon, I just want to thank everybody today who's going to be teaching me, because I'm going to be going to these talks, and have a wonderful day 2.